Good afternoon, everyone. So I'm Gopi, and I'm here to talk about Vishark, which is a visual Wi-Fi troubleshooting tool. I have with me Robert, who is our senior technical marketing engineer, and he is going to show some cool demos along with me.
Hello.
And Robert is known affectionately as Mr. RF, and you can figure out why that is. He has got a lot of experience in WLAN performance analysis. I have been with AirTight for last 11 plus years, and I come from an engineering and R&D background. And as I said, I'm going to talk about Vishark, which started as a project that was meant for our own purposes. We had a lot of issues in terms of troubleshooting Wi-Fi. We used to get requests from the field. We had our own issues in terms of the Wi-Fi that we were using, and we wanted to have a good solution for that, and that is how Vishark was born. So it initially started as a night job for Karan, who is a creative engineer in our team, and myself. Karan hacked up most of the code while I was analyzing some of the customer issues and suggesting some product improvements. He also came up with some good visualization techniques which have been implemented in Vishark. So ever since WFD5, where we launched it as a private beta, we have come a long way, and thanks to the feedback of the beta users and also some of the WFD delegates, we have come quite a way, and that is what I want to share with you. The improvements that we have done are fall under three dimensions. The first one, we have basically made some improvements to the features. We have added some cool new features, and then we have made some response time and architecture improvements so that it can scale better. And third, and not the least, so we have made it a part of Mojo Studio. If you remember, in WFD6, Praveen, our CTO, had promised that we will deliver Vishark as a part of Mojo Studio, and I'm happy to say that we have achieved that goal, and we will be showing some interesting stuff there. So to begin with, why did we think of actually building this at all? I want to tell you a little bit of story, and this is something which we have experienced. I would be interested to know whether some of you may have also felt the same. So this is a typical problem that we try to solve, right? When we get a issue from the field or from anywhere, we try to get a packet trace and then open it in WizShark. WizShark is a cool tool. We all love it. So the problem looks something like this. So we spend some time on it. It starts looking like this. So it's a little bit, it faded a little bit. And spend some more time, it becomes hazy. And we are wondering what is happening. And till after some point of time, it starts looking like this. I know I'm exaggerating things a little bit here, but for somebody who is looking at traces day in and day out, I'm sure we can relate to some things like this, right? And how often have we encountered situations where the problem is not in our deployment, but it's with some other third-party device? So we spend frustrating days, nights, and sometimes weekends to actually figure out what is happening, and then realize it's nothing to do with us. But then, because customers are important, we have to debug and solve the problems. So this was a problem that we were facing, and as the saying goes, necessity is the mother of invention. So we were wondering, what can we do to actually do our lives better, right? At AirTight, we have also given a term for this phenomenon. We call it packet trace fatigue, where our mind gets completely exhausted. One's mind gets completely exhausted, and we wonder why Wi-Fi doesn't work smoothly, right? So what is the answer? So I've always believed that a picture is worth 1,000 words. When I showed this picture to my daughter who couldn't read, she jumped with joy saying that this is an ice cream. She can't read the verbose text. So that is when the thought appeared, why not try to apply the same idea to packet troubleshooting, Wi-Fi troubleshooting, and see how it goes. So this was purely a thought experiment to begin with, but as time progressed, we kind of tried to give it some shape, and we wanted to really see if picture is worth 1,000 packets. So Vishark tries to do the same thing, and it abstracts the trace into different visuals so that we can see what is happening at a high level, and we can also try to do some analysis to get to the root of the problem in a much more easier way. And just as a clarification, and thanks to Keith and some of the other folks who have been active on Twitter on this front. So we are not trying to replace the human brain or the need for knowledge. That's definitely not the intent. We are just trying to provide some better troubleshooting tools so that the process of troubleshooting is more enjoyable and it becomes fun. That's the idea here. And on a related note, I was speaking at SharkFest last month on WLAN security, but it was interesting to know that almost 1 out of 4 talks were talking about using visualization techniques for troubleshooting TCP/IP networks. For example, TCP Trace, which is a wonderful tool, and there was another talk on Steel Script. So that was really good. And at AirTight, we are really proud to kind of apply this to Wi-Fi troubleshooting and be one of the thought leaders in this space. So with this background, what I will do is I'll quickly jump on to a demo of Vishark and show you our experiences in debugging some real life case studies and how we have been able to use this. And as always, feedback is most welcome, and I'll jump on to the demo now. Yes. So what we are seeing here is an example or a baseline trace where we are seeing a client connect to an access point and start some data communication, right? And the y-axis represents the different packets, types of packets that are specified in the .11 protocol. We have ordered these packets in a specific way, and that is in such a way that packets which come at the initial part of connection, the probe request packets, authentication request packets, they are kept at a lower level, and as the connection progresses, we actually trace the connection. So what this helps us is to kind of quickly see how the client is behaving at a very, very high level. So if we see the client actually connects and then there is a plateau of data communication or data packets, then yes, this is a healthy connection. So if it is not, then we can start wondering, is there something wrong? So that gives a very good indication. And as you can see, so we have some interesting features built around this, and we can zoom in to the extent we want so that we can get a more closer visibility, right? What we are seeing here is the authentication packet, the response. Similarly, the reassociation client is reassociating to the AP, the response, and we go on to the EAP handshake, right? And finally, there is a EAP success, right? And we can also implement, we have also implemented things like looking more details about the frame, which is one of the things, for example, Blake had given a good suggestion on, and we have done that. And what we are seeing here is the fact that the client has completed its EAP handshake, gone ahead and done the EPOL 4-way handshake and started the data communication, right? So this is kind of a baseline trace which I would like to kind of come back and kind of contrast with some of the real life case studies that we will be using. So what we are seeing here is a dashboard which captures the trace at a very high level, and this is something which is useful because at a glance we will see how the packets are behaving, right? So this can be used in multiple ways. For example, we can look at the client that is there or the client that we are interested, or we can also see, try to sort on some packets and see whether there are any usual suspects like deauthentication frames or dissociation frames or such failure frames that are there with any specific client. So what we are seeing now is basically a trace dashboard. That was the client communication dashboard. This is the trace dashboard. For the time being, please bear with me. We will not tell you how the clients have, how the traces have come here. We will cover that very shortly. Assuming that the trace is here, I will show you one real life case study that we actually solved using this tool. So to give you a little bit of background on this case study, So this actually happened, as you can expect, on a Friday night, Friday evening, when we were trying to wrap up, and there was a call saying that this issue has popped up, and then we need to figure out what is happening, right? And the beauty of this case study, as we will see, is that as like any other real life case study, it has multiple problems associated with it, not just one problem. It was not as simple as the user was not able to connect to the Wi-Fi. He was able to connect to the Wi-Fi, but he was facing intermittent disconnections, and also the throughput was low, as we can expect. If we can see this trace, two things that I would like to call out here. The first one being, we are seeing some kind of a wave-like pattern here, which we did not see earlier. This means probably that client is trying to reconnect again and again, right? And the second thing I would like to call your notice is there are some big red blocks that we can see, and our attention naturally gets focused onto this place. And we have done that deliberately. And the reason for that is we have identified some key events like deauthentication failure or disassociation failure, and kind of want to make sure the user focuses his or her attention there, and then kind of try to zoom in and see what is happening here. And let us start with the first problem that is associated with this case study. Let me zoom in a little bit. So we are seeing some golden stars or asterisks here. There are multiple of them. So this represents the client is actually hopping between multiple APs, two APs. One AP was quite near to the client. The other AP was far from the client, was in fact on a different floor. So even though the client was stationary, the user was sitting in one place, actually Wi-Fi client was hopping between multiple APs. So this is something which we have found hard to explain to people, because people normally associate client hopping to user actually moving around. So when we say that user is not moving around, but still it can happen, it is difficult to convince people. So this clearly indicates that that is happening. And if I would kind of show you a little bit of what this frame is, this is actually a reassociation request frame. Let me zoom in a little bit, right? So the beauty of this frame is, even if client is hopping to APs across channels or in different channels, this will tell what is the current AP and what is the next AP. So that way we don't have to capture packets on two channels and then do all the merging and stuff like that. Just by looking at this packet, we will be able to infer that the client was actually hopping, and we can clearly see that client was doing it in this case, and that was the first problem that we can associate with this client, right? And this is not the worst of it. There are multiple problems, the other problems, and let me go to the second problem. Yeah, so let me go to the wave and try to see what is happening in this wave. So we are seeing a deauthentication failure that is sent by the AP to the client. So why is this deauthentication packet there in the first place, right? So if we notice the connection a little bit more closely, we are seeing that the client is actually sending an association request with PMK ID count as 1. So what does this mean? This means that the client is telling the AP that I already have an association with you, and I have cached your PMK, the master key, right? And as a result, the AP is starting the EPOL 4-way handshake, which is what it is expected to do, right? However, unfortunately, for some reason, the client is again going back on its word, so to say, and saying that it would like to do a full-fledged .1x handshake, not the fast roaming. So that is why there is some kind of a state mismatch between the client and AP, and it takes about a minute to two for the client and AP to connect back, right? So how does the client finally, how is it able to connect? So as we can see here, right, the client has, the AP also resorts to full EAP handshake For some reason, at this point of time, we don't know why it happened. Our suspicion is the fact that the AP has some state or some timeout maintained with the PMK cache, and probably that got timed out, and hence the AP also started resorting to the full EAP handshake, and both of them came in sync, and we see a successful connection. That successful connection can be seen here with EAP success packet, which confirms that yes, the connection is there, and they have now moved on to the data handshake phase. But it took a minute or two, and clearly it's very noticeable to the user, and user was naturally upset, right? And this is the second problem that I talked to you. So now let us look at the third problem, which is again interesting. Right. So this is the data part of the communication that is already going on, right? If you notice, there are two kinds of triangles here. Triangles actually represent the data packet, and there is a big triangle and there is a relatively small triangle. So what does that mean? So a smaller triangle captures retry of the same packet. So we have captured retries in a very visual way, because retries are a very good indicator of the health of the network in some sense. We know, yes, if there is a lot of retry, then the RF channel is bad, or there are a lot of collisions and stuff like that. So we have given special treatment to that. And what I'm going to show you now is there are some filters that are there in the tool. You can play around with it yourselves rather than me explaining all the features. Now I'm looking at only the client packets. This is with respect to the client, and what we can see is that there are a lot of retries happening, especially with the client. Now, what I can do with the tool is the fact that I can also superimpose the data rate view on this, which is going to be powerful. So what it is going to tell me is what is the data rate of the client and how is it actually varying. So if we can see, the data rate of the client is not at all high. It's about 18 Mbps, right? And this is a 11N network, so we expect it to be much more higher. It is quite low. And we also see instances where data rate actually modulates. So this clearly indicates that we can superimpose these views and try to get some idea about how the channel is looking. And in this case, poor RF channel was also contributing to the user experience. And these were the three issues that we actually were able to identify in this trace. Yeah, please go ahead.
Do you have a field for nav time in here? I love this, by the way. This is great. I mean, especially when you overlay the phi, because then you can see the shift. Yeah. With high retries, it shifts down. I mean, this is a great visual. Yeah. But what about nav timers? I mean, we're starting to see some devices that take up exceptional amount of time.
How would you see a nav timer is not in the air?
Well, you're going to see the frame, and you're going to see the nav inside the frame. So you see how much time. Is there something that shows?
I can show you too later. Time? Yeah, we do have it in one of the other tools which we're developing, which is going to get linked to this. We do have a nav timeout as well. Yes. So, for example, this clearly indicates the rate adaptation that you are mentioning. The client actually is facing some problem, and it is very clear that this was one of the main issues that we saw, right? And if you notice, I used this, right? This particular space in the visual interface, we call it some kind of a trace guide, and this can be used to zoom in, zoom out, and move around in the trace. And if you notice, there is another area which we call as the overview guide. So this gives a representation of the entire trace, right? So what this will help us is to look at the overall picture and see if there is a problem in the trace, potential problem in the trace. In this specific example, we do see here that things are going smooth, right? But notice here towards the end, there is a dip here, and let us see what that dip is. Let me just remove the data rate view, and what we are seeing is the fact that that dip indeed is another reassociation. So this kind of gives us a bird's eye view in one single screen, and this we have actually helped in debugging several issues. By the way, any guesses how we solved this specific problem? Yeah, so we just updated the client's driver and it solved the problem.
That never happens.
Yeah, so we were lucky probably, so we were able to do that. And that kind of shows that a lot of times we debug issues which are not related to us, but then we have to do, and that is the reason why we kind of developed this. So this is one of the case studies that I wanted to cover. So there is another one which Robert is going to cover and also show us some nice workflows as to how trace can be uploaded to WizShark. So while Robert comes here, give me just 10 seconds. I will make sure that he is ready for the next demo.
So is this something I can capture from the AP? I can capture this all? Right, yeah, we're going to show that. So we're going to show 2 ways to capture from the AP. Of course, if you have a trace, we'd capture with a MacBook Air or something, or MacBook, whatever. You can drag and drop it. And the first workflow we'll show is a drag and drop. And to your point, about the superimposition, where you can look at the conversation that the AP is having with the client and see the impact on performance, or at least on data rate, and then also frame size. And for doing a lot of performance testing, I find that really illuminating. And also you can look at QoS, so you can see that. And so it's not designed necessarily for performance monitoring, but it certainly has the capability of moving in that direction, helping out with that. All right, so I'm just going to spend a little bit of time on this trace. This is another problem that one of the employees had, and took a little bit of troubleshooting, and this tool helped us solve the problem. Now, I'm not going to tell you what the solution was, because it's actually a video that's built in, a case study video, and you can go through that and you can see what the solution was for this particular problem. So we can look at it. We see, again, just like we saw with the authentication, association, and then we see the EAP start. But we notice a red error code here. And if you look just to the left of that, you'll see that there was an attempt at making host authentication. And you can see that basically at that point, there was an error returned by the access point. These are all, again, this is the AP view. The client view. There's also another perspective. You could see it from the AP's point of view, but since we're looking at it from the client's point of view, this is all, if you see a transmission, that's from the client. So now, I also wanted to share this because one of the big advantages of this tool is the ability to collaborate. So George has kindly allowed us to share this particular workflow or problem that we had. So what we're going to do here, first we'll unclick this. Now, if we click this checkbox there, we're going to see that it's made for public access. So George doesn't have to have it, access to WizShark. We're going to send him this link via email, and he's going to be able to then open it up and start helping out with the troubleshoot. So we'll do that.
So while Robert pulls his mail client to send the trace, so a small perspective on this particular case study. This was again a case where the user was not able to connect at all, and what we wanted to basically do is to see where the problem was, and this was different from the previous case where the user was able to connect, but here he was not able to connect at all, and that led to a lot of frustration, blaming our Wi-Fi. But when we go to the solution, when you yourself seeing the video, it is very clear the issue lied elsewhere. That is the
right. And also, before I move on with the help, there is a built-in help file which has the decoder ring for the symbols and the color of the symbols, and so you can find that there. All right. Now we'll go to the workflow 1, and for the first workflow, we're going to be using an access point right there on that table. It's a C55 11N access point, and we're going to be capturing local. And by the way, I should point out that it's not going to be service interrupting. So that's an AP. It can still service while we do the capture. We're going to send that capture to this local host, and we'll pop open WireShark, and we'll see that. So let's start. So find the C55. It's the top one here. Click that. Go to More. Start a packet capture. We're going to, again, stream it local. So we'll say Start. And when I do that, I'll just get the command that will copy, then run that. Get that buffer warning, and watch this for a little while. And I get trace fatigue faster than you, Gopi, so we're going to stop this and then save it local.
So this is what we call as live streaming. And this is very useful in enterprise environments where everything is in one network. We can sit on the console and see what is happening in a very remote office.
Okay, and that will go to the desktop. Minimize that. juggle these around. Back. I'm going to get back to the home page for WizShark, where I'm able to then drag that, drop it, and it opens it up.
So this is one of the ways in which we can get trays onto WizShark. And if you can notice, we are using standard PCAP format, and we can support files from anywhere. I mean, it doesn't have to come from our own AP or sensor. So it can come from anywhere, and people can use this to look at what is happening in their Wi-Fi trays. So this is one of the workflows, as Robert mentioned. One point I would like to call out here is the fact that this does not work in certain scenarios. For example, we have a cloud deployment, or we have an MSP scenario where devices are deployed in distributed offices and they're all over the globe, and either the IT staff is very thin or the IT staff is not that technically trained, right? So that is the scenario that we are talking about, and there are a lot of customers we have seen who are like that. For example, one of the recent issues that we got was from Siberia, right? That was a customer which had office in Siberia, and there was no staff at all. So how do we get traces from such environments without having to bug the customer? This is a problem that we have seen ourselves. We have to request customer to get us the trace, and customer is also not happy, and or we have to have somebody fly there, which is also not a good solution. We have seen this ourselves. So we thought we should have a better way of collecting packets remotely without having to bug the customer, and that too as seamlessly as possible. So that is what Robert is going to show us now.
All right, yeah, so we're going to use a tablet. So we're at a cafe or somewhere, and we're going to do the second workflow, and we're going to capture it directly to the server. This time, I'm actually going to use the C75. It's a 3-stream 11AC AP. It's not here local. And so I'll highlight that and do a packet capture. And this time, we're going to upload it to the server. But before that, let me just point out that, of course, you can have filters on the capture. And if you wanted, you could strip the payload data away or capture filter on any type of packet.
Do you take any kind of performance penalty doing the capture on the AP?
Not that much, because we are capturing the packets that the AP is already serving. So we just tap into that at a level where the we don't do any extra computation, we just tap it.
Is AP listening to not just packets between itself, but is it listening to packets between other APs and clients?
So basically there are two modes in which we operate. If the AP is a pure AP, then it is listening to only its traffic. But if it is doing background scanning, then it can listen to other traffic that is on the same channel. This is all on the wireless side.
All right, so you can see that we started that capture. Go over here and take a look at that. And I want to stop it, highlight that, and stop it. Now I can go back and look at that capture, previously packed. And we can see that that's the one I just captured. And now we can hit that, and it will pop up on WizShark. And you can see that it's processing. And there it is. And that was all sort on MAC addresses, and it was this Apple client. I have an iMac sitting a cube away, and I'm just doing a ping. And we can overlay the data rate and see what it rate adapted down to. And yeah, there it is. It's hard to see back there, but it's about 1.2. So that's three spatial stream 11AC, pretty close.
So thanks, Robert. That was very nice. So just to conclude the talk, so what Robert has done is the fact that he is sitting here and able to collect trace from an access point or a device that is completely in a different network, that too using a mobile device that does not support WireShark, and he was able to upload it with the click of a button onto WizShark and view it visually. And all this is a part of our Mojo Studio, and it is single sign-on enabled. So with that, I would like to conclude my talk, and thanks very much for your time, and to all the viewers who are watching. So if you have any questions, I'll be happy to take it up. Otherwise,
there's one question on Twitter. There's Tom Carpenter asks this, says, so if you want to capture packets on other channels, you still have to take the AP down, right?
If you want to capture the packets on other channels, yes. But the thing is, we also have a background scanning mode where we do that without disrupting the AP. We can't collect all the packets, but we can get a good enough sample. It depends on why we want to capture the packets.
Thank you.
Yeah. Sure.
Out of curiosity, just a rough percentage of calls that you might get from your customers and it ends up being a client-related issue, like a driver you said. I'm just curious, is it 50% of the time, 60% of the time it's a client issue?
Yeah, so that's a good question. Initially when we launched our product, yes, there were some issues with our devices, but now that the code has stabilized, I would say it's more than 50%. It is the issue lies elsewhere, but we got to debug that because they are our customers. So we spend a lot of time.
And one last question with that. Do you guys actually work with the clients, like the Apples and the Intels, and share this information? Is there collaboration between the two? Because from an end user, I have to tell you, that's one of the largest challenges I have, is the client.
Yes.
One thing that's consistent is my infrastructure.
Yeah.
Yes,
that's a good question. Unfortunately, at this point of time, we are not doing that, but that's something we can.
Something that may help, though, there's the ability to take a shot and save it as a JPEG. So if you were writing a report, you could actually show them with the visualization, like the issue. So if you look at the video, that's a good one that you might want to take a shot of to show that it was.
Yeah.
Yeah.
Good one. Thanks.
Yeah.